probably what, 400 feet up. Stuff to say to that.
And you'll be widening the tunnel too?
Yeah, we're going to widen it to just over 3 metres, 3.5 metres wide by just under 4 metres high. I think we have the correct term.
I mean to get actually get the stuff out, you're putting holes in and blowing it up.
Yeah, you see there, that's what a face looks like drilled. These are 38mm holes, 40mm holes. These are drilled by handheld machines, but basically you drill them at sort of half a metre apart, 40 centimetre apart patterns. Load those with explosives, back them off, and that will cut out this chunk of rock here, throw it on the floor, come along with the loaders and get up, put it in the truck, out. That's about the size of rock that you get out when you blast the face, sort of fist size and a little bit bigger. That face has been blasted but hasn't been cleaned. So. There is the Cononish vein. You can see on the left hand side you see a very dark rock. You can see the black rock, and then you come to the right of that and you can see it's going from white. There's a very sharp contrast between the two there. And you carry on across there. In that corner, just in that corner, you can see instead of being white, the rock turns grey. So from there, from that contrast on the black there to that area, that's the width of the vein. You can see, if you look above your head, it's got lots of quartz in it. If you then look down straight the way down the tunnel, you'll see the vein. You can just more or less see the white rock. You can make out the contrast between the white and the black rock there. You can see that the vein is just running straight the way down the drive like that. You've got 600 foot of rock above your head at the moment. Runs up more or less in the centre of that tunnel there. That goes up 50 metres vertically and connects with one of the old adits in the cliff face. The veins about 20 metres in the wall, we know that because 3 of the drill holes that you'll have seen the core from. So NX drilled those holes in 1989, 1990 and found the vein does actually extend there. So we know it's over there, but why they put the tunnel here, I've got no idea. No. They did anyway. Cutting through the rock, that's what we call the Izani fault. If you remember as you came up the glen, the whole of the left-hand side of the hill is a little bit further forward than the other side of the hill. That's basically the fault line along which the left-hand side of the hill has slid. It also means we're in a position now where we're actually just going underneath the cliff face. So we're just in front of the waterfall in the watercourse and about to go straight into the middle of the cliff face there. So if you actually went up 400 or 500 feet here, you'd find the vein outcrop on the surface, but we've still got to go on a little bit further to find it. The aspect of how a quartz vein sits in the host rocks. We've got this sequence here of sort of grey and white coloured rocks. This is the host sequence, the samites and peelites of the Dalradian sequence. You can see they're sort of lying at an angle like this. That's the host sequence, and then you've got a quartz vein running through it here, which is running at about 60 or 70 degrees, 70 to 80 degrees. You can see it cuts in a plane across the side of the drive like that. So this sort of gives you an idea of the aspect of how a quartz vein sits within in the sequence. We're going to wander onto this isn't the main Cononish vein, it's in front of you, but when you get there all you'll see is it's sitting above your head like this, so you don't get an idea of the aspect of how it actually sits within the sequence. What you can also see here is you can trace this band of rock, bumps into the quartz vein, that's gone. Yeah. So this is also a fault plane, so there's been movement along here which has moved that bit of rock relative to that bit of rock. It's also, I think the fault plane is a fracture, and that's provided a path for the fluids underneath to come up. Potentially you've got some kind of granite or hot body underneath here, which is making a convection cell of water within the rock that convects the hot water and the pressure down there. The rock dissolves minerals from the host rock and maybe from the granite, and eventually they find a way out, and the way out they find is through a fracture. As they come up through the fracture, the temperature changes, the pressure changes, minerals exalt, and you get a quartz vein or a vein forming. You can see this is quite white quartz here, which generally means it's not very interesting, but on the side here you've got a little bit of greyer stuff, which is what you saw in the drill hole. These are two separate phases of quartz. Normally when we see grey in there we get quite excited, but in this case it's obviously very narrow, and if you look down here it's basically disappeared. So that's just a sort of like a squirt of toothpaste being added to that vein that's not really very interesting. Probably does carry gold, but it's not as consistent as we need it to be of any interest for us. But anyway, let's just give you an idea of the aspect of how quartz vein head is a Cononish vein. What you see on the left-hand side, you see a very dark rock. That's it's very useful for us here because it just provides a contrast between the host rocks and the veins. It's actually what we call a dike. It's an igneous intrusive. It's come up after the vein, and it's a basalt or a dolerite type dike. It just provides a nice contrast between the hosts and the vein itself. So if you look there, you can see the black rock, and then you come to the right of that, and you can see it's going from white. There's a very sharp contrast between the two there. And you carry on across there. In that corner, just in that corner, you can see then instead of being white, the rock turns grey. So from there, from that contrast from the black there to that area, that's the width of the vein. You can see, if you look above your head, it's got lots of quartz in it. If you then look down straight the way down the tunnel, you'll see the vein. You can just more or less see the white rock. You can make out the contrast between the white and the black rock there. You can see that the vein is just running straight the way down the drive like that. Aspect here is about 60-70 degrees, so if you can imagine this going up above your head for 600 feet, and then if you follow it right the way to the top, you come out on surface because it outcrops on surface. So you're about 600 foot of rock above your head at the moment. You can't see, we showed you the drill core, or Frankie showed you a bit of drill core there. You can't see those characteristics in the vein here because the vein was put in place, and then this thing came along and it's hot and it's disturbed it, and so it's destroyed some of the characteristics of the vein that you would normally associate with it here. So we're going to go past this thing, and then you'll see the vein looking much more like what you see what we showed you in the core. Yeah, I think that's it.
So you said this actually outcrops on the surface then?
Yeah, there are about 3 or 4 spots where it outcrops.
Wow.
Most of it's covered by peat and hell and everything. There are a couple of places where you can actually you can see it outcropping. So you can trace the outcrop for 600-700 metres along the surface, but it's been trenched and then it's been filled back in again.
And this is the concept you go after the miner.
Sorry?
You go after this to mine it.
This is what we want. That rock there, even though it doesn't look like it, contains about 10-11 grams a tonne of gold. This bit around
Per
here.
tonne.
Yeah.
That's seriously.
That's a good grade. That's a good grade. It's gold £1,000 an ounce. 10 grams is £300. So there's £300 worth of metal in each tonne of rock that's sitting there. That might seem a lot, but because there's two differences in the temperature and pressure regimes, you get different types of quartz forming. That vein is about 350, 360, somewhere around that, whereas this one is 410 million years old. Remember, I'll show you on the way out, but there's an old lead adit in the side of the cliff face there. That connects up through to that, and that's where the fresh air comes in through here.